So now here we are at the end of Unit 3, the human population and its effects. We've talked about the size of the human population, how it got to be there, the impacts of urbanization, the impacts of some of the toxic chemicals that we produce. And now we're going to talk about what we do with all that waste that we produce. I'm going to get into a little bit of legislation in here too. So we're going to look at how we manage waste, some of the issues with the waste we generate, how we can reduce that waste, how we dispose of that waste, and the idea of hazardous waste and how we deal with that. So waste, by definition, is any unwanted material or substance that comes from a human activity or a process. And we put waste into different categories. Municipal solid waste, which is abbreviated MSW, is non-liquid waste that comes from homes, institutions, and small businesses. It's what goes into the dumpster or what goes out to the curb at the end of the driveway in your trash can. That's municipal solid waste. Industrial solid waste is waste from production of consumer goods, mining, agriculture, and refining and extracting petroleum. So from industry, waste from industry, that's solid. Hazardous waste is any material, solid or liquid, that's toxic, chemically reactive, flammable, or corrosive. And then wastewater is water that we use and that goes down the drain or gets flushed. All right. There are three ways that you can manage waste, three parts of waste management. You can minimize the amount of the waste that we generate, so you can reduce it. You can recover and discard materials, recover discarded materials and find ways to recycle them. Or if you can't do the first two, then you need to be careful of how you dispose of waste safely and effectively. So we talk about the waste stream. Kind of sounds like exactly what it is. It's the flow of waste from where it comes from to where it ends up, all right? And we can take a look at the waste stream. So this is all of the waste that gets produced, the stuff that goes out to the curb, industrial waste, all of that. So one way, a big, relatively easy way to deal with reducing waste is something called source reduction. So you reduce the amount of waste at the source. So you have low waste packaging, you bring your own bags, all that kind of stuff. So you do all of these things, reusing items, recycling items, composting materials, which then reduces the amount of waste that makes it to the end location, either the landfill or the incinerator. So what they call this linear movement from the previous slide that goes from production of waste to disposal is called cradle to grave, because it's where it starts to where it ends. But a lot of manufacturing is doing something called cradle to cradle. So you take materials from products at the end that are reused and put back into new products. Water bottles, a lot of water bottles, the water bottles that you get from the store are made from 100% recycled plastic, okay? Recycling and composting. Composting is converting organic waste to mulch or humus. There's only one M. 2 M's is humus, 1 M is humus. Through decomposition, a really important part of this cradle-to-cradle approach, and really emulate the natural matter cycling through ecosystems. These are considered recovery because they're pulling waste out of the waste stream. So it's some of those arrows that went off to the right in the previous slide. Municipal solid waste, which is MSW, is trash or garbage, and there's a lot of components to it. The left-hand side shows you what the typical composition of trash is. It's mostly paper, food scraps, yard trimmings, and plastics before recycling and composting. After recycling and composting, there's a lot less paper, but still quite a bit of plastic and food scraps. Waste generation has gone up in the last 60 plus years, because we are consuming more, right? We are the materials that we purchase are overpackaged, okay, or the goods that we buy are essentially disposable. There's a lot of argument as to whether that's a function of manufacturing or, do they not make things like they used to anymore, or are things, are they discarded while they're still useful? There's a lot of debate about that. In the developing nations, waste production and consumption tend to increase as affluence increases. People have more disposable income. So as these developing nations develop, landfills and waste becomes more of a problem. People in these countries that do not have affluence and wealth will wind up scavenging dumps, landfills, kind of like this one, and selling those items as a means of income. So it's a very sad picture, but it's a reality. In the developed world, we've improved waste collection and disposal. Most of that waste is this tan color. It's going to landfills. Okay. Over the course of time, we've seen increases, well, not really increases in combustion, definitely increases in recovery for recycling and composting. The best way to deal with waste is to reduce waste. So packaging is really one of the ways that we can reduce waste. The banning of plastic bags has been helpful in reducing our waste. So you can buy produce unwrapped, or if you buy produce, bring one of the reusable produce bags, or buy food in bulk, bring it in a container. So that way you have, like in the bulk almonds or anything like that, rather than the prepackaged stuff. Manufacturers can also be aware of their packaging, right, and change their design of their packaging to make it recyclable or make the containers smaller. And you see that sometimes. Improved package design or improved bottle design. And this is true. We are living this in New Jersey right now. Governments have restricted plastic shopping bags. You can't get them in New Jersey. You can't get them across the river in Bucks County in Pennsylvania. They're paper bags if they provide bags. Some things that you can do every day to reduce that waste stream, instead of throwing things away, donate them to charity, reuse boxes and bags. Make your photocopies double-sided. I do that for the most part in our class. Buy rechargeable batteries. Spend a little bit extra money to buy goods that are going to last longer, clothes that are going to last longer, rather than this idea of fast fashion. Thrift stores are another really good way to reduce waste. Composting, you can do this. A lot of you guys may have a compost pile or a compost bin at home if you have a garden or a farm. You take organic waste, food scraps, and yard debris, and you turn it into mulch or humus through decomposition. You expose it to bacteria. Make sure there's a good worm population in there. You can put certain things in a compost bin or a compost pile. You can't put meat products. So you take that stuff that you would normally dump in the trash can and create a natural fertilizer. That's good for your soil, it's good for your crops, and it also reduces the waste stream. If we're going to recycle, things have to be sorted first. Drop-off locations and curbside recycling are the two most common strategies used by cities. I know where I live, we don't have municipal recycling. There's a spot, that my husband takes all of our recycling when the bins get full. And then the township has an agreement with solid waste removal companies to empty that bin periodically. That stuff winds up going to a materials recovery facility where they separate the recyclables, because we have commingled recyclables. You can put everything in one bin. They use magnets and water currents and air classifiers to sort things out based on density. And once it's sorted, it can be processed to manufacture new goods like plastic water bottles. There have been various programs that have increased the amount of recycling. In 2013, about a quarter of our waste stream was recycled, whereas 60 years ago it was just about 6%. You can do a trash audit where trash cans are emptied and you remove recyclable materials. So that's something that we can look at doing in our cafeteria if anyone would be interested in through the Environmental Club. Recycling is a challenge for a couple of reasons. First of all, certain things are recycled more than others. So newspaper, batteries, cans tend to be recycled quite a bit. Plastic isn't recycled as much as it should be. Tires are definitely recycled. And the recycling rates across the nation vary quite a bit, okay? In New Jersey, we're in a pretty good spot. Pennsylvania's not too bad. Pacific Northwest and California, they have a pretty heavy push for recycling. But there are places, all of those reds and oranges, that the recycling rates are really, really low, okay, 20% or less. So it doesn't happen everywhere, and there are certain things, as you can see in the table on the left, that are recycled more often than others. So what's the challenge? Why is recycling not widespread? Okay, let's talk about plastic or metal, two of the things that we tend to recycle the most. When oil is cheap, right? Plastic is a petroleum product from oil. When oil is cheap, it's actually going to be cheaper to make new plastic than it is to recycle old plastic. So again, it's the cost-benefit analysis. If it's cheaper to just make new plastic, they're going to make new plastic, right? If it's more expensive to recycle, they're not going to recycle because they don't want to spend the money. So again, is it necessarily the right environmental choice? No, but that's how the world works. Most of the costs are environmental and most of the benefits are financial. All right. When the market price for metals are low, right, it's going to be easier to go through that mining and refining process than it's going to be to recycle, scrap metal and pieces of metal that exist already in the world rather than doing the refining process. So there's the issue. Those market prices that we talked about, as I had said, don't reflect the external costs of not recycling, okay? Like the greenhouse gas emissions that wind up being created as a result of these processes. So this is the annual rates of gas reductions due to recovery of various materials in the United States. So we recovered 43 million tons of paper. That was equal to 31 million cars coming off the road, right? So again, if these external costs were accounted into the value of these processes, it would be a no-brainer to recycle plastic, okay? 3 million tons will give us 750,000 cars off the road. This data really kind of shows you the value of it. So most of our plastic was heading over to China. So a lot of the recycling happened in China. But a few years ago, they really cut back on the imports of recycling because it wasn't beneficial. It wasn't worth their cost. So it wound up putting a big damper on our recycling market because we were relying on China to do our recycling for us. Little known fact. A big issue in the United States, a big issue in our cafeteria, is that we are trying to recycle things that we can't recycle. So if plastic jars of spaghetti sauce still have spaghetti sauce in them. You can't recycle them. You have to rinse them. Okay. So the recycling, the sorting of that recycling is not as good as it should be. So you wind up with higher rates of contamination, which allows that material not to be recycled. So around here, it's called the pay-as-you-throw garbage collection program. We pay for our trash to be picked up, and it's definitely not cheap, you know, if it's picked up in a dumpster or the end of the driveway, depending on the amount of bags, depending on how full the can is, etc. One way that we've helped to increase the recyclability of some containers is through these things called bottle bills. They used to be a lot more prevalent than they are now. Most of the states down here don't have bottle bills, so the recycling rate is kind of low, right? Michigan and Oregon have a 10% deposit on recyclable containers. So for every can or bottle that you take back to a store, you get 10 cents on it. They charge you 10 cents extra, but if you return them, you get that 10 cents back. So recycling rates are generally higher when there's a financial incentive, which makes sense. Okay, so anything that doesn't get recycled, composted, etc., that makes its way to the end of the driveway to be picked up as municipal solid waste winds up going into something called a sanitary landfill, right? So it's a big old pile or a pit in the ground that's engineered to allow waste to decompose, but yet prevent it from contaminating the environment, okay? So there's a law, a piece of legislation that you need to know that governs the maintenance and standards around municipal landfills. The EPA created it, and it's called the Resource Conservation and Recovery Act, or RCRA. Came out in 1976. So it designates the design and maintenance of landfills. So let's take a look at what a landfill looks like. So waste is partially decomposed by bacteria, right? And that's this darker stuff here, and winds up compressing under its own weight. So it takes up less space. As decomposition takes place, volume decreases, and it also gets squished by the stuff over top of it. So in between these areas of waste, right, this darker brown, are layers of soil, okay? Soil has natural bacteria in it, so it speeds up decomposition and it reduces the smell. If you've ever been past the Schrin landfill on 78 as you're heading into Easton, heading west on 78, off to the left, it's this big giant mound, okay? And it's very smelly in the summertime. So layering it with soil helps to reduce odor and then reduce pests like rats and all that lovely stuff. So the bottom of the landfill, at the bottom, above the water table, okay, is this yellow layer, which is a layer of compacted impermeable clay. Impermeable means stuff can't get through. So it's this layer of impermeable clay smushed down really, really hard, right, to prevent anything from coming through, and a layer of plastic. This red orangey color is plastic. So it's like a giant plastic bag at the bottom of the landfill, right? So then above that is a gravel layer, which is allows material and water and stuff to percolate through, but the plastic and the clay layer don't allow it to get into the surrounding soil. It's not foolproof. It does leak sometimes. So that material, that liquid material that comes from decomposition, is called leachate. It's one of the grossest words in environmental science, leachate, okay? So any of the toxic materials that have been produced as a result of decomposition that are liquid are going to go down into the bottom and get removed through this leachate system, okay? So it's going to get pumped up, collected, and treated. Sometimes that leachate is toxic and it has to go to a toxic landfill, toxic waste landfill. But these landfills, there's very specific requirements, parameters for their location. Can't be near a wetland because the ground is just wetter, so leachate has a better chance of leaking. They can't be in earthquake zones, which makes sense because if you have any shifting of the crust, you're going to have leaking of this landfill, and it's got to be at least 6 meters, a little bit more than 18 feet above the water table to prevent any possible contamination from leaking landfills between the groundwater and the leachate. So eventually the landfills get full, they get capped with soil, and they, in a lot of cases, become public parks. So Fresh Kills Park, Staten Island, when it was operating with all of the seagulls and all of the trash, now it's full, they capped it, they planted on it, and it's a park that apparently kids can go play baseball at. So if you don't put it into a landfill, you can burn trash. Incineration, combustion, burning trash, it's burned at a really high temperature, okay? It reduces the weight of the waste by 85% and its volume by 95%. So there's still waste that comes out of it. The ash can then be taken to a landfill. When it happens, it just takes up less space. So the solid waste gets delivered, it gets burned, right? It turns, you can, in some plants, in many plants, you can use that heat to boil water to turn a turbine to generate electricity. So that's called trash to electricity. They do that in a lot of cases. So as this trash burns, there are toxic gases that come out of it. So they get treated with a scrubber. So that material winds up, some of those toxic chemicals wind up falling out into the ash. Some of that particulate matter also needs to get filtered through something called a bag house. Okay, you can see it here. Material passes through and gets filtered. That air that is scrubbed and filtered then comes out of a smokestack. Any of that ash that's left through the boiling process, the scrubbing process, or the bag house process, then will leave and get disposed in a landfill. So it takes up a lot less volume than this initial solid waste. So that's the idea of waste to energy that I had talked about. It generates about 35% as much energy as burning coal. So it's not as effective as coal, but it's a better use for our waste. And inside landfills, as bacteria do decomposition, they produce something called landfill gas, which is about 50% methane. The Schrin landfill, I did a project on the Schrin landfill when I was in grad school, and there was a lot of controversy around the Schrin landfill at that time because they were trying to build a pipeline that took the methane from the Schrin landfill to their main offices about 5 miles away. So instead of relying on fossil fuels or other sources, they were going to use the methane waste from their plant and take it to power their offices. So they avoided my phone calls for, I don't know, almost 2 months because they thought I was, trying to give them a hard time. I'm like, no, I just want to talk to you about your landfill. I'm a grad school student. Sometimes you can recycle materials in landfills. You can dig into landfills and pull this stuff out to reduce the volume in landfills, to reduce the pressure on landfills. It makes sense to do that when the market price for these materials is high enough. You could go in and make compost, if the market price for compost is high enough. All right, so that was municipal solid waste. Now let's talk about industrial solid waste. Industrial solid waste is waste from industry, whether that's mining, factories, agriculture, okay? They use similar methods in industrial waste disposal that we use in municipal waste disposal. If you look at who regulates what kind of waste, because, we're we're humans and we like to regulate things. The federal government, through RCRA, regulates municipal solid waste. State and local governments deal with industrial solid waste. So the rules for industrial solid waste are generally less stringent than those for municipal solid waste, which can cause some problems. An industry tends to base its practices on economic efficiency. Okay, so where you produce less waste per product because it's more expensive the more waste you produce. So industrial ecology, if you're into manufacturing and business, you can look at industrial ecology. So you take engineering, chemistry, ecology, and economics, and you work on systems in industry to make them physically and economically efficient, okay? With the idea being, have things function as much as you can in a way that mimics natural ecosystems, where organisms use everything that they produce. There's very little waste, but it's going to require change. One of those things is a life cycle analysis to look at how you can make things better, to take waste and do more of that cradle to cradle rather than cradle to grave idea. Not use harmful products and make products better, make them more durable, recyclable, or more reusable, which is going to cost money, and people don't really like to do things differently. They like to do things the way they've always done things, which is the challenge. All right, hazardous waste. Hazardous waste has at least one of four characteristics. It's ignitable, which means it can catch fire. It's corrosive, which means it's going to corrode metals in storage tanks or equipment. It's reactive, which means it's going to react with other substances. Or it's toxic. It's going to be harmful to humans when inhaled, ingested, or touched. If it fits at least one of those categories, it's considered hazardous waste. There are so many different kinds of hazardous waste that are currently in your house. Paints, batteries, oils, solvents, cleaning agents, lubricants, pesticides. It's probably, most of it is in the garage, in the basement, or under the kitchen sink or the bathroom sink. A lot of these organic compounds are toxic because they are similar to what we talked about. They're classified as chemicals that we talked about in the last chapter. Mutagens, carcinogens, teratogens, and endocrine disruptors. And they are persistent, right? So they don't break down, and they are fat soluble, and they bioaccumulate and biomagnify like DDT. Okay, so they are toxic. They are considered hazardous materials. E-waste has become a thing, or electronic waste. It's gotten a lot worse because of the short lifespan of these products. And these materials, these phones and calculators and computers and other things, make their way into landfills, okay? They have a lot of hazardous waste in them, okay? Heavy metals and flame retardants, they wind up being treated as hazardous waste, okay? So it's gotten better in the last few years, mostly because the devices are smaller, so they require less of those heavy metals and other kinds of chemicals, toxic chemicals. But even then, a lot of more of them are being recycled, which is a good thing. The Olympics in 2020 in Tokyo, they did a huge drive to an e-waste drive to collect metals to make the Olympic medals out of. So it was, I forget the statistic, but it was some huge number of devices that were collected to create these metals. It's pretty cool. The case study we're going to talk about this chapter is on Love Canal. It was a place in upstate New York near Niagara Falls that was the site of a hazardous waste disaster. Okay, so before Love Canal was a thing in the 1970s, anything that was hazardous, you know, it was just discarded. It wasn't given any special treatment. RCRA from 1976 said not only gave regulations on how to handle landfills, but it also required states to track hazardous waste from cradle to grave, okay, from where it originates to where it ends. And it's got to be collected at certain spots. Like in Hunterdon County, there's a hazardous waste drive where you can take your paint cans and your batteries and drop them off. They have to go to a special place, and there's a picture of one of those kinds of drives. Okay. If you are a facility that generates, transports, or disposes of hazardous waste, you have to track it. You have to provide paperwork for all of those steps from cradle to grave. So it's not cheap to do that. So a lot of companies are going to illegally dump the waste, or they're going to export it to developing countries because they'll take it for cheaper than it's going to cost to track it cradle to grave. So what do we do with hazardous waste? We do one of three things. We create something called a surface impoundment. Okay. It's a little pond that's lined in plastic, again, which is impervious, and probably something like that clay at the bottom of a landfill to store liquid hazardous waste. Okay, so it's liquid hazardous waste out in the middle. The water evaporates from the waste, so that waste, that solid part, that chemical part is left behind. And then once there's enough of it, they remove it and they take it somewhere for permanent disposal. There were a couple of those surface impoundments just south of the Regal paper mill, the Crown Vantage plant the Regal paper mill in Frenchtown. Okay. So now that's, that was considered part of a toxic site, which we're going to talk about in a second. Something else you can do is to drill really deep down into the earth, into a porous rock, right? A rock with holes in it, and you inject the waste into that. So here's what that looks like. Problem with that, we use groundwater. So depending on where it is, you can wind up polluting groundwater. And as you change the rocks below the surface, you can induce small earthquakes. We're going to talk about radioactive waste again when we get to chapter 20. It's really dangerous to human health, and it is persistent. It doesn't go away in human lifetimes. We don't have a designated spot for it. There are other countries that do have one spot for all of it. It was supposed to be in Nevada, but enough complaint made it not happen there. Currently, waste from nuclear power plants is held in storage, dry storage, or wet storage at various places across the country, at various plants. Military nuclear waste, from bombs and stuff, is in New Mexico, in an underground salt formation that is apparently geologically stable, but the Earth's crust changes, so who knows how long that's going to stay stable. So after Love Canal, in response to the Love Canal disaster, the U.S. Congress passed something called CERCLA, the Comprehensive Environmental Response, Compensation, and Liability Act. You need to know what is CERCLA, okay? So CERCLA is what happens after there's been a hazardous waste spill, okay, or some contaminated site. It created a site cleanup program called the Superfund, right? So the EPA then also became responsible for cleaning up brownfields, which is the land that contains hazardous materials. So when a Superfund site is identified, scientists take a look at it to see how contaminated it is and how close it is to homes and how much of a threat it is, okay? How much of a risk of exposure it is for people in the area. So as of 2018, there were over 1,300 Superfund sites, and only 413 had been cleaned up or otherwise deleted from the list. And we can take a look. The Crown Vantage site, the one in Frenchtown, was deleted not that long ago. So we'll take a look at it when we go over our key points. And that ends our conversation of landfills and managing our waste. And it's also the end of Unit 3.